and today we're going to get started in on building a 50-ton hydraulic shop press. This is really exciting to me because I've never even used a shop press before, but I decided to build one, partially because I have a legitimate need for one, partially because I think it'll be a cool project and thus a cool video for you guys, I hope, and mostly because I've watched one too many videos on the hydraulic press channel. Alright, so the way we're going to put these sides together, we're going to build this like a piece of square tube essentially, a piece of rectangular tube. So there's one plate wall, another plate wall, then there's the center of the press, and then two more plate walls over here. And the way we're going to fit these things together is with some dual shield flux core welding. It's really fast and really strong. And we're still going to go all out on the joint prep here because anytime you have something designed to withstand the weight of two fully loaded semi-trucks, not really the kind of thing you want to cut corners on. So we've got these pieces which are going to form one section of the wall, and then there's these which are going to form the other section. And the way I'm going to have this figured, you'll have to pretend like this is 71.5 inches long. But instead of just taking this piece and putting it here and welding straight across the top, so the weld pretty much just sits on the surface and doesn't penetrate very much and isn't capable of holding that much, what we're going to do is we're going to take this backing strip we just CNC plasma cut out with the Hypertherm, and we're going to toss that under there, and we're going to put our 71.5 inch long piece here with a gap, and then we're just going to fill this in, and to optimize penetration and fusion, we're going to bevel both sides of this. So got the old 7-inch Hitachi, and nothing to it but to do it. This is going to be a pain, this is going to be labor intensive, but beveling 2, 4, 6, 8 feet of 1/4 inch plate with this really shouldn't take too crazy long. One of the great things about a ginormous anvil grinder like this, you think it'd be really hard to use, and in some respects it's actually easier because it weighs so much that the weight does a lot of the work for you. So you don't have to push into a piece of metal like you would with a 4.5 or perhaps a 5-inch unit. Now that we have the wide sides of our pieces of DIY rectangular tube ready to rock and roll, it's time to get set up with the front and back. Now, not only are these front and back sections going to get welded to our side pieces, of course, we're going to have all our holes drilled in these, which is what the pins are going to run through to secure this press in place. So I've decided that I want these things to be 5 inches wide, since I'm going to weld them over the front of the pieces of, over the fronts of the sides. You know, we'll have a little overlap on the sides to make it easier and faster and stronger to weld to, and should be about 4.5 inches wide, you know, between the two pieces of rectangular stock. So the way I have this set up is essentially all I'm going to do here is make a mark every 5 inches or so. I find that little arrowhead type marks like this are really the way to go on something like this, because if you just make, you know, a single scratch mark like that, it can be hard to tell, you know, which part of it is exactly where you need it to be. So I like the little arrows myself, and I don't know if this level is going to be long enough. No, not quite. Alright, so this part isn't 100% ideal, but we'll make it work anyway. I'm just going to put 3 sets of these marks at 5, 10, 15, and 20 inches. And now what I'm going to do is I'm going to take this level and line it up, and then I'll mark here, and then I'll scoot the level down here and mark here. Not ideal, but on a longer stretch like this, sometimes it is what it is. The sides of this thing laid out, at least one side. We have 4 of these components, and there's 2 per side of the press. And the way I've got this set up is we got our larger section and our shorter section, which we're going to weld together. Now, needless to say, this has to be a very, very strong weld. All these sides need to support the hydraulic pressure of roughly 2 fully loaded semi-trucks. So they got to be pretty sturdy. And the way I've decided to do this is with an open, with a completely beveled joint, so we'll get full penetration on each side of this plate. So we've got this valley here to fill, and since I don't really want to do this open root, I've just placed a backing strip in here. So when we make our first pass, we're going to tie the backing strip and both plates together completely. So I mean, this thing's going to be fully fused together, and then we'll add in another couple passes. I got to be careful that I don't do this all at once and end up warping these things. That'd be bad. but I think we can get this whole together pretty well. Man, I love it when you're able to get your ducks in a row and things just plain and simple work great. Not always that lucky, but sure is nice when it happens. It's in the opening stages of starting to look like something that resembles the side of a press. So you guys can see these are the pieces we've been welding together so far. This is where we joined them. This is the back side of that backing strip. And now the plan is really simple. We're going to take some of these shorter sections of plate and put one here and one here, and then the longer sections of plate with the holes drilled here. So what this is going to do is give us two sides essentially with all these holes, so we can position the, I'll call it the anvil of the press, as high or as low as we want. You know, we'll just run a pin through there and it'll hold things in place. And so I've been thinking about how I want to do this. Again, since we don't have 8-foot long material to work with on this project, we kind of have to join all this stuff together. And I'm going to put a short section here and a long section here. That way our weld, we have one weld here and another there, and I think this is going to be quite a bit stronger having them interlock like this, if you will, versus putting both welds right here, because then theoretically it'd be a lot easier for the top of the press to get sucked off. I don't think that's going to happen, but with something like this, you really want to build it as sturdily as possible. So, alright, I'm pretty excited about this. I got a couple magnets set up here, and we're just going to put a couple tacks in here, keep this in place, and then set up the next section. So, let's see what we can do here. Gotta turn off the grind mode first. Turn the bag. Just have to come up just a little bit. I know it's tedious, YouTube, but getting this right the first time, even if it takes you a little while longer to mark stuff out, is totally worth it. Now, if you can't tell, we're going to be doing another open root weld right up in here where these two pieces meet, but I'm going to wait until we have both sides fit up to do that. So 12 inches there, went a little far, a little more, 12 inches there, great. Alright, so everything here looks pretty good. Yeah, exactly where I want it to be. So here's your quick little fabrication tip of the day, YouTube. Anytime you're working with something that's, you know, a flat strip of material like this, it's very common that it's going to have a slight bow to it. So what I've learned to do is it's really best if you have to curve out like this as opposed to going in. You can see the natural tendency of the strip material is to bow out like this, and there's a reason for that. I have this end secured with two pretty decently sized tack welds here. So now, in order to fix this bend and remove it completely up against this edge, which we know is about as perfectly straight as we can get it, then all I have to do to fix it is go like that. See how that bow just completely disappears in there? So the opposite of this is having it bow like this, and in order to do that, I'd have to put a lot of force here. I'd have to like clamp it across here. It'd be a total pain. Whereas with this, it's really easy. All I have to do to get rid of that bow is have it curve out, and I just push this in, and it's ready to tack. Alright, so it's really close to the way we want it, and since we've been beating on this, I think the next logical thing to do is to apply heat to it. And I'm not going to do this in the conventional way with like a rosebud torch or anything. We're going to strategically weld this in a very specific way. because when you weld things, to an extent, they're always going to warp. On some things it'll be very noticeable, on other things probably not noticeable at all, but there's always some level of warpage there. And one of the ways you can counteract that is to plan out what you're doing and use it to your advantage. So I'm going to weld this weld seam here, and it's going to cause this plate to come this way in relation to the bottom plate. And when it does that, it's going to work to pull this straight. So I'm going to weld this first and let it cool, because I don't want to warp it too far and have the opposite problem, the one we have now. I'm going to weld this, let it cool, then weld this, which is exact opposite of it, and let it cool. And that should pull at the last, I'm going to say about 7 degrees or so that we need until this thing is perfectly straight. Here's your welder and tip of the day. So when you're working on a long joint like this, and you may be wondering how am I supposed to stabilize my hand, because if I do the old this thing with one finger here, you know, that's only going to get me so far. What I like to do when I can work along the edge of something that's parallel to my weld joint is basically what y'all just saw me do. And I'll have a couple fingers here. They're underneath this table, so they're not going to get hot, at least not fast enough for me to notice. And with this, I can traverse as far and as long as I want to. So let's see, we'll start about there. Can't complain. So now that we have this first tube laid out and welded, we use the heat of the weld to pull this thing to, I'd say within about a 1/16 of an inch of perfectly square. Could be a little bit better, but honestly I think that's as close as it's going to get, and for what we're doing with this, I don't see that causing any problems whatsoever. So we got this fully welded out, and now we're going to be building the pins which actually hold the anvil of the press in place. So, you know, there's that big section which can rise up or down, and then the hydraulic cylinders up there. The section that you press things onto, that you rest stuff on when you hit it with that ram, it's going to be held in place by 4 pins. And in order to construct this, we'll be using this 1-inch solid steel cold rolled bar stock. And so I think what we're going to do next is actually make these pins, because I have to use one to like put through here and lift this whole thing by to get this off here, so I can get the other 4 pieces on and get the opposite side to this one welded out. So I've decided the way how I want to do this is I want this to be 22 inches long, and you'll see why momentarily. So I'm going to put a mark at that end and a mark at this end here. Okay, so we now have 4 of these pins, all nice and turned to length, and Seth here sanded off the burrs and the rough edges, so I like them. You know, we got this nice knurled grip here. I think it looks really cool. It's a great texture to latch onto, especially once this inevitably gets covered with hydraulic oil like every press part I've ever seen. I haven't even seen that many. So then on the other end, we've got this tapered section, and the great thing about this is when you ram it through the body of the press, it's really easy to sort of catch the side of the hole on the other side with just a part of this, and then it pushes the pin through it, like guides itself in. So that would be the main reason for that. So one other thing I considered design-wise when I built this press is with this, we kind of have to stab around and feel around in there. However, I've seen some people, and when they build these, they take a piece of pipe and they run it through, like from the inside of this hole to like the inside of that one. So all you do is you catch this and you just ram it straight through, because like I said, it's a piece of pipe. I think it's kind of cool. I decided against it because it's a lot of added material, a lot of added weight, and a lot of added money. But, you know, something to think about if anybody ever builds one of these at their own risk. So we have that. Next problem is we have to drill a hole right where these two pieces of plate meet. You can see this weld seam right here. And it's just sort of the way it worked out. We drilled one every 6 inches, and these holes are 6 inches exactly from the center of this. So we got to stick a hole in there. And you may be thinking, how are you going to do this? Wouldn't it suck to pick up this whole probably 500 or 600 pounds, maybe not 300-400 pound beam here and carry it over to a drill press? Yeah, that wouldn't be that great. So we're gonna use the old mag drill here. And since it's a mag drill, it works out of position with the force of magnetism. So I'm just gonna get this set up. I'll put the ejector pin right over the side of this. So now I'm just gonna let this thing down. I'll stand back as far as I can to safety through. Now we're gonna lower this thing all the way down onto the floor. Then we're going to fabricate the second side of this on the bench, and then we'll probably end up using the gantry to hold these things as we weld them together. Now we gotta build a few parts before we can actually join these, but we're making pretty good traction, and now that we have the piece done, it's looking even better. Yeah, I'll leave it just like that. Cool. Alright, time to weld together the second side. Make some more progress on this press, YouTube. So you can see, looking at that end, we've got a spacer piece for the bottom half of the press, and that piece of pipe is the same exact length as the piece of channel, which you'll see over here by me. So what this means is that when we go to lay this gigantic other sidewall of this press on here, you know, we'll have a nice rectangular structure, and it'll be parallel with this big beam here. So the top of this thing is going to have to take a lot of force. So what I've decided to do is use 3 pieces of this 6-inch heavy wall channel. It's almost 3/8 of an inch thick. There's this one in the middle, and then we're going to run one out each side like this. And when it comes to fitting something like this up, one of the best things that I could advise someone is have a good, solid, flat work surface like this table. This thing is almost perfectly level, both X and Y axis and so what that means for us, since the top of this isn't perfectly level, is all we have to do is rest our piece of channel iron on here and get it sticking straight up, and so it's not cattywampus and cocked over sideways, and then we'll have a good, strong, sturdy square press. So looking at these levels, we can see that this piece of channel, it has to move in like that. It has to move towards the camera a little bit, and it's obviously really hard to hold something exactly where you need it to go on a setup like this. So the way how I'm going to do this is I'm going to use heat and warpage to our advantage. I'm going to weld this seam here first, and then the heat from that is going to pull this channel iron in. Now if you're not careful, this can pull something out a square. If you are careful and you play this like a game of 3D chess, it can pull something into square. So that's what we're hoping for. Alright, I'm gonna be very careful not to bump anything out of the way as I go to strike the arc. Very high power short circuit MIG. That's like the absolute upper limit for short circuit MIG. We're almost into spray. And you know, I'm gonna switch these levels because this one's got some overspray on it. So now you can see, if we look up here, this bubble, it's traveled just like that, about half as far as it needs to. We still have to move this a little bit over further though. So the way I'm gonna do that is kind of push on this and see what we're getting into. And while I'm pushing on it, I'm gonna push it a little too far, then weld this face and let it get sucked back a little bit. I'm all shaky and jittery there. Look, it's just about perfect. Another degree or two, and that would be ideal. Now, for those not familiar with channel iron, it's really strong in a perpendicular type force. Like if I was the hydraulic ram and I'm pushing in like this, it'd be extremely difficult for me to bend this like such. This is about the only way it's strong, because when you look at it sideways, it really, in the grand scheme of things, doesn't take much to bend these little like 2-inch tall side lips. So even though this is structurally probably going to be just fine for what we're doing, on a press, there's really no such thing as an underbuilt shop press. So what I want to do now is take this thing from being a three-sided structural shape to four. We're going to box it in. If I had any heavy wall box tube this size, I would use that instead of the channel. But I don't have any, at least to spare. I have some, but I have to save it for another project. So we're going to box this in. One day, YouTube, one day I will complete an entire project without the use of extreme hillbilly hackery, but today is not that day. Basically, the problem is somehow this one beam is tilted in just a little bit, so the whole thing's too cattywampus for that thing to fit inside of. So we have this 12-ton air hydraulic jack that was, well, that's a story that's literally its whole other own video, but we're gonna try this thing out since we have it anyway. No one seems to want it back. And it just might be the tool for the job here. And so it's less likely to go flying or fall and kill one or both of us. I have used baling twine to secure it to the rafters of the building. So I'm gonna gently hold on to the bottom here in order to give this thing a good solid start. Do something. It's not a Torin brand jack, so I expect it to work right at least once. It's moving. All right, now it's the part where we see if it actually spreads these beams. Hey, this jack might be all right. Let's see though, the room busters are wide enough for this to lay in. Almost. Now with every second we're working this thing, the sketchiness factor increases exponentially. Do not try this at home. Okay. Oh, it's so close. I'm afraid we're gonna break one of these tacks. We're in. We are in YouTube. How about them apples? All right, now I need to go in here and remove the jack so the sides of that channel clamp down on that other leg. And then we can free up the gantry. Once that's securely in place, we can free up the gantry to pick up the back side of this and lift it up. The sketch factor is real, YouTube. Sketch factor just got a lot lower. So it works right out of the box, which is good, but it does leak air. At least it works. I've had such poor luck with hydraulic jacks and bottle jacks. Literally, I was in a welding job and we needed a bottle jack for something. So one of the guys there went to buy one. It was a Torn brand one. Didn't work right out of the box. All right, any words? Okay, that's out. Sketchiness factor lowering by the second. Makes for a crappier video, but makes me a lot happier. Now what we need to do is set this channel iron further down in that gap. I'm just going to lower this just a little bit. So we have gravity on our side. Okay, good. And whatever you do not trust those pieces of channel because they could pop off at like any minute. And if that happens, they're going to fly. So make sure you're not like right where they're headed. And ideally, a fair ways back. It's coming in. We keep accidentally lifting this end off the table. We need to like clamp it down or something. We use one of the handful new production, somewhat properly built C-clamps in the known world. Okay, that ought to do it. Yep, it's staying. All right, so we're trying to do this in the safest way possible. However, the danger risk of something going horribly wrong with this, it's still there. We're not completely out of the woods yet. Basically, we were able to just lift up this end. Yes, it's a 300-400 pound beam, but with two people pivoting one end, when it's already like chest height, it really wasn't that bad. So that's resting on top of the pipe over there. Now, I'm still a little concerned about these pieces of channel flying off and launching, which would obviously be bad. So what I'm going to be doing is trying to move this piece back. As you can see, it's an inch from the bottom of this pipe to the bottom of this piece of steel. So this has to move like 2 inches this way. And then we'll basically be there. So we have to be very careful not to stand. Anytime you do anything remotely like this, and again, I certainly don't recommend you try it at home, you have to be very careful to always be thinking about what's going to happen if something fails and where it's going to go, and then not stand there while you're working on stuff. But unless we have major problems after 3, 4, 5 sets of tack welds, this thing should be rock solid, and then we'll be able to probably weld it out in position on the bench and then we'll be able to lift the entire thing off the bench, set it down on the floor, and then flop it back up with the gantry, and it'll basically be done. Then we just need the anvil to add the hydraulics. So, just, right? I know. Okay, let's hope the best. It's moving. Still getting there. One of the keys to safety in an environment like this is to realize just how weak and fragile a human is around 100-pound pieces of steel, 7 feet in the air, under tension, or for that matter around anything. All these tools and equipment, as a person, even if you're a really strong person, automatically the weakest link in any of these equations. So you kind of have to think and act appropriately based on that. Okay, that looks about decent. Needs like 2 more whacks before this is an inch from this edge. Maybe 1 more whack. It's there, great. Let's see, 5 1/4 to that edge, just a little under. 5 1/4, just a little under. All right, this end is very luckily exactly where we need it. Watch your eyeballs. Great. Where's my helmet? There it is.
Face shield for welding.
I don't consider that to be that bad if you catch it before you actually strike the arc. Good news, we no longer have to worry about this end falling off and killing one or both of us. Yeah, more second-rate YouTube videos for you guys to watch. Alright. Actually, maybe I shouldn't speak too soon. Alright, so this looks good. Before I tack this end, I'm going to take a tape measure and make a few measurements, because if I tack this in here wrong, it's going to be really bad if I find out about it once we have everything put together and it's on the ground. For those wondering, I thought about fitting this up on the ground, but if I do that, then we obviously can't secure it to the table. And although this might look like a little bit of a pain, we really have to have both ends clamped down for this to work properly. Alright, outside to outside, 45.5 inches. 45.5 inches. Exactly. I'm pretty proud of that. That side at least couldn't be closer. Okay, watch your eyes. It's solid, YouTube. Whatever the future may hold, this thing's not popping off and flying. Nothing left to pop off and fly. All the corners and ends are secure against each other. So now I have to decide if I want to weld this out like this or try to do a bunch of this stuff vertical once we stand this thing up. so the good news is that this press, the sides of it are almost perfectly level in terms of this or that a ways. And so now I think what we need to do is toss some legs on it so it'll be infinitely less sketchy for us to work around. And looking at this, in hindsight, I wish I'd had the legs ready to roll so we could just zap them on with the welder right now, but we don't. So I'm gonna make the legs 5 feet long. That should keep this thing from tipping over. And we have some smaller, I think it's like 4-inch channel left over from another project, which is gonna be pretty much perfect for this. Get that real tight. Great, now we're going to take this and cut miters like this on both ends to make it a little safer and a little better looking. We're going to use the bandsaw for that. Now mitered all 4 cuts here on both of these 2 pieces. Now the secret when it comes to miter cutting stuff like this, it's pretty obvious what I was going for here. I wanted one end sloping down, the opposite end sloping the other way, partially for looks, partially so you're less likely to trip over this thing or catch a pant leg or a shoelace on it or whatever, partly as a safety concern and partly for aesthetics. The secret to this is to like quadruple, triple, 7 times check that you got these angles going the right direction, because if you're not careful, you'll do what I've done more times than I'd like to admit, and you end up with one end slanted like this and the other end slanted like this instead of like that. Rage-inducing, waste tons of material. All right, so now we have these things cut. Let's see how they look on the press itself. All right, so these are going to go on here something like this. We'll take some measurements so this is actually properly centered. And the new problem is, obviously anytime you do something like this, you really want to weld on both the top and the bottom or close to the bottom of this, like one weld up under here, one going in like that. Problem is we can't really do that without lifting this press up, which I'd strongly prefer not to have to do. So what we're going to do is we're going to toss this thing on the mill, and we're going to mill out a slot like this, and then we'll slot weld our slot. And that way we'll have metal attached down here and down here, because if we just weld it up here, it'd be really easy for this to like twist off or bend off and lose a lot of strength and potentially cause an accident or get somebody hurt. All right, so the plan here is pretty simple. Since our press is about 12.5 inches wide, I decided I want an 8-inch long milled out section so we can tie in pretty well to everything. And the plan is, all I've done is I found the center line of both pieces of channel, which happens to be right here. And now I'm just going to trace out a couple of rectangles, and 4 inches there. Yeah, I'm just gonna trace out a couple of rectangles here. And what we're gonna do is we're gonna toss this on the mill and mill out everything in between the rectangles. And for this, I want a nice wide, very well defined, very easy to see line. So now we're going to start in on building what I refer to as the anvil, which is the adjustable height. We'll talk about that later. Adjustable height section of this, which you actually rest things on in order to come down and smash them with pressing the press face here. So looking around on the internet at some other 50-ton presses that are available commercially or that have been home built, generally I see that the anvil pretty much just ties into one hole. Like, you know, it'd be this wide, it would tie into this hole and this one, and that's that. So I want mine to tie into 2 holes per side for a total of 4 holes all the way around this thing. And there's a number of reasons for that. You know, someday if I'm really cranking on something, maybe theoretically off in the future I'll upgrade the hydraulics, which probably isn't very likely, but always a possibility. So essentially the weak point in this are these holes. They're gonna start to get wallowed out over time, and if we connect through here with 2 pins instead of 1, then I'm not an engineer and I have the mathematical abilities of a 3rd grader, as most of you guys already know, but they're not gonna wear twice as slowly. They're gonna wear like 3 or 4 times as slowly, because there's you know, different areas being worn at the same time, and it's gonna be evenly distributed between them. So yeah, essentially we're gonna design this anvil so it ties into 2 holes, so we'll need all 4 pins to hold this thing in place, but once it's in place, it should really be in place. So we're just gonna measure these holes, and these things are about as precise as can be done by hand with a mag drill. And it looks like we have 40 inches and a quarter across here. 40 inches and 1/8 across there. So this is gonna be the same pretty much all the way down. So we need this to be 40 and a quarter apart hole-wise. So what's half of 40 and a quarter? 20 and 1/8. So we're gonna take the 20 and 1/8 and put it right over our center line. And we're gonna confirm these measurements here momentarily. 40 and a quarter, all right, good. So now, this end is 6 3/4. This hole is 6 3/4 from the end of this. You'll see why it's designed like that in a little bit. And this end is 6 3/4 exactly. All right, so from here, we're just gonna make absolutely positive the ends of this are lined up properly. And then we're gonna mark across this. Just like that. And just like this. And so that's gonna be our center line for the holes, and now all we have to do is decide how far down into this piece of channel iron we actually want to drill. Alright, so I'm working on the outsides of the anvil of this press, and looking at these pieces of channel iron, you know, channel is very strong through a perpendicular force. Like if this was laying as it is on the table and I were to push it about here, it'd be extremely difficult to bend. However, as most of you guys know, the part of this is going to want to bend and deform the most is going to be the middle, essentially, in the interior section here. So what I've decided to do is to box this in. We just cut out this piece of plate, laid it on here, and now we're getting it ready to weld. So I've decided that I don't want to fully weld this because it doesn't really need to be fully welded due to the structural design of this. That would be overkill. And also when you fully weld something that's going to flex, oftentimes it'll be weaker than if you intermittently stitch weld it, because with the stitch weld type design, then your weldment can actually move and flex a little bit, whereas if you just weld straight across, this thing would be really rigid and more likely to crack in the future. So I'm gonna put a bunch of little chain welds across this, and I want this thing to look fairly decent, since you're gonna be looking right at this when you're using the press. If I screw it up, it's gonna be really noticeable. So I'm gonna set this to like I'll set it to 6 seconds. And so now when I start welding, we're just gonna weld for 6 seconds, and the machine will stop me, and this should give me even in length welds all the way across this piece. I think we can go a little longer than that. Alright, this is going pretty good now. Don't put your foot under this. We just got done pulse stick welding this thing that I refer to as an anvil together. Basically, all this is a piece of some pretty thick plate. This happens to be 3/4 inch plate. And so what we do with this is we made these three brackets, I guess you could call them, these three pieces of material. I had Seth cut them out. He did an awesome job on it. Look at this, even around the corners and everything. And the way this works is this is designed to resist warpage and bending and to transfer this force evenly into the pieces of large 6-inch channel iron that make up this section of our press. So all we do is we flip this over, and the angled sections of this should guide it right down in between these two pieces of channel. Just like that. Man, that fits in there really well. I think there's some spatter that's making it sit a little sideways because it fit about perfectly before we weld it. We'll clean it up and take care of that, but basically now the thing is, you know, if we have to press on something, we have a good, solid, sturdy work surface here that we don't have to worry about bending because we have all those gussets on the back side of it. And so now when the mighty 50-ton cylinder ram comes down and presses in on this, we don't have to worry about bending anything, and we got a nice place to get our work done. Alright YouTube, so now that we have this whole anvil section welded together, what we need to do is come up with a way to raise and lower this to accommodate various size objects that we might be pressing upon. And so what I've decided to do is I bought a couple of these hand-powered winches. They're like the same type you'd use to pull a boat onto a boat trailer if you have a small boat or whatever. And essentially the plan is, what we're going to do is we're going to take this piece of, I believe this is 4x4 box tube, we're going to weld it out here about as high as you can comfortably crank. That this plate is going to go over the front of it like that. And these winches, which I kind of have taken apart here, they're going to go on the plate like such. So all you have to do is come over here and crank on this thing and it'll raise and lower the anvil stands. So I guess the next thing for us to do is to get these holes drilled out and then tapped, and then we're going to try and put this whole thing together here. Alright, so we got the holes drilled, and now Seth is going to try his hand at tapping this. And he knows how to do this. I've shown it before. And there's not that much to it. Basically, you just have to make sure you're going in perpendicular to the materials he is, like both X and Y type, and plow through it. Now they say, and this is good advice, if it's thicker material, if it's harder to turn the tap or anything, then you only want to go like a quarter turn and then back up until you feel the chips break. But with this, we're really lucky. You know, we have a razor sharp tap, perfectly sized hole. Sometimes you don't have the right size bit or whatever, so you're ramming out a little bit more material. And so it's pretty easy to just go straight in there, and there's not really anything to worry about. Yeah, look at that. And now the threads are cut, but we're just going to run this down a little bit more to clean said threads. Make sure there's no burrs on them, make sure they, you know, bolt threads in there really nice and everything. That is it. Yeah. Now back out. If we were smart, we'd do this on the mill so we wouldn't have to do it by hand. I want to try some power tapping on that thing. I've power tapped with other stuff, but you know, for just a hole or two, it's not really worth the time it takes to get the mill set up. That's awesome. How was it? Pretty nice. Great.
I like the taps.
Just one left. Yeah, these taps will sort of work to correct themselves if you're off by a degree or two on your angle, but you know, you can't go in with a 30-degree offset and expect decent results. Ah!
All right, now.
Yeah, that's a problem I had. I built this vise before I had a milling machine, so the jaws aren't actually parallel, like they're bowed in a little bit from the heat. At some point we really need to mill that flush, but who knows when that'll be. You're doing it, Seth.
Yeah, we got it.
Yeah, we got it, man. Totally got it.
A little bit more resistance than the last tool, but that's probably all the chips that I still left on the tap. So
Tap there. Yeah.
got
You're doing
old
it.
chips and new chips.
Yeah, this is awesome.
Oh yeah, smooth as butter now.
Ah, we like that kind.
All right, looks like we're fully tapped, gone all the way down.
See, there's really not a lot to this. I have people ask me all the time, like, how do I tap this? Is it really that difficult? Do I need expensive stuff? No, not really. There's really not a lot to it.
All right now. Don't
All right.
drop your taps now.
That happens. That actually happened to me too. I don't know what's up with that thing. But great, we got 2 holes. Now let's put this together. Alright, so now we're getting these brackets put together, and I'm welding these out with some 3/32 inch 7018. You know, it's we're welding with some thinner material here, so we can penetrate the depth of this and fuse also into the side plate here without having to worry about burn through as much as we would with traditional non-pulse stick welding. And it also makes it really nice working with some of these corners here, and momentarily we're going to be attaching these to the outside of the press up in here. And I will say that there's quite a few advantages to the pulse stick welding process for out of position welding, which we'll get to experience then. So let's wrap this up and get these winches mounted. So now we got to figure out exactly where we want to put these pieces of tube, and this right here is within an inch of where the hydraulic cylinder ends. So, you know, I'm really glad I built this thing so it's, I believe, 8 feet tall, because this way, you know, if the cylinder ends here, then, you know, you're working at about chest level with your part for optimum comfort and visibility. So I think I want to set this, these winches up about here. This is about as high as I can comfortably turn that handle. So we really only have to measure these out because we want this to be repeatable on both sides. If we were only putting one winch on one side, we could get away with just eyeballing it. But I think I want this to be about 20 inches down. That's a good easy number to remember. And I'll make a couple marks here that we can connect momentarily. And how wide is this whole press? I think it's like 12 and a half or so. Yeah, 12 and a half, 12 and 5/8 exactly right here. So let's see. That's about our center point. Yeah, it's a little past our center point. Inch-long tack weld, so I can manipulate this any way necessary. And I can already see I've got to twist it in a little bit, but other than that, I think it's on here almost perfectly. Yeah. A little bit more. Gotta try not to snap this thing off. We're getting there. Alright, that's good on the level. It's good eyeballed. It's always important to check both because sometimes they're not the same, and if one's wrong, usually it's not level. Despite how it may look on the level, there might be something under it or whatever. All right, it's on there. All right, so the last thing I welded up was this big piece of channel iron. This is some 8-inch channel with like a 3/8 or probably closer to a 1/2 inch web on it. And this is what the cylinder is going to mount to. So this is going to rest right up in here. And since I don't really want to compress it, as you can see, I've added these 2 pieces of plate, which just got welded in here. So now these pieces of plate will directly contact this main support beam up here, thus transferring almost 100% of the force from the ram that's going upwards into this sturdiest part of the press right here. So jumping back onto raising and lowering the anvil for a second, you know, we're gonna have our winches right up here with the crank that you crank, and the cable that runs down from that needs some way to attach onto the anvil itself. So what we've done is we took some scrap 3-inch angle iron and we're gonna put it in here about like this. And that just leaves us needing something to actually hook our little cable to off of this thing. And for that, I've decided to use these. Now, probably 6 or 8 months ago, I put a mild lift kit on my F-250 shop truck to kind of counteract the weight of the winch bumper I added to the front of it. And it was a pretty tame lift. It's only like 2 or 3 inches in the front, but it was still enough that we had to replace the U-bolts, and I saved the original U-bolts off the truck, knowing I would need them for something or other one day. And so these are actually what we're going to cut down, and then we're going to stick one of them on like that, so you could just hook onto this and raise and lower the anvil like such. So let's see what we can do with these. Nice. Alright, so the next piece of the puzzle we need is a shelf of some sort, which is going to hold this hydraulic power unit. So we got 5 pieces of metal here. We've got our base plate, which is pretty self-explanatory. And then we have these sides, so the hydraulic power unit doesn't like fall off the side. And the front, we took and milled out this section so you can still access the drain plug on the front of that power unit. And so we're going to put these together about like such. And then this is going to act as a gusset, which will go underneath the shelf like that and work to support the weight a little bit more. Let's try and stick this together with a powerful, very reliable HDP MIG 2400. Alright. Yeah, we'll put that about there. And here we go. Alright, now I will say there's really no reason to weld this all the way out. This is an excellent candidate for stitch welding because this entire shelf has to support about 80 pounds and there's a gusset that braces it from below. So welding this all the way out on all the seams and the inside and outside is complete overkill, even by my standards. So we're just gonna kind of stitch weld this together and mount it up on the side of the press there. We like it? Yeah. Alright YouTube, slight change of location. I was thinking about it and I said to myself, you know what, if we put this in here, because that press is fairly tall, so if it's tall enough to be able to be put in and out, then there's a slight chance that it'll interfere with attachments which we're going to build to go on this ram, like for instance press brake. And so I thought about putting it outside the unit. I wanted to put it up on top of these Frankenstein bolt looking things coming out of Frankenstein, the press's neck here. But, you know, in order to do that, the lever is going to be like way up here, which is manageable for me, but barely. It's not comfortable, and for most people, it's not even manageable, so that wasn't going to work. And so we figured we'd set the thing up right here, because now, you know, it's really nice. You know, if I got my piece in here, I'm just working away, you know, I reach up, handle's in a very natural position. It's out of the way, it's easy to actuate. And the other thing is, if I'm ever pressing anything that's really sketchy, like I hope not to, but we all know will probably happen, I can actually stand behind this beam and I can reach over like this and actuate the press, and almost all of my body is safely protected and out of harm's way. And so that's another advantage of this. All right, let's let it cool. And you know what? I think it's time to paint this, because obviously I'm not going to be trying it out before we paint it, because it's going to make a huge mess. We'll have more to clean up. So yeah, let's break out the acetone and the wire wheel and a hammer and chisel for a couple of these BBs and some masking tape, and let's do it. All right, it's painting day, YouTube. We got to get this press ready for paint and then paint it up. YouTube? So I'm like a little kid in the candy store right now because we finally got this thing working. Honestly, it didn't take much. You know, we fired it up, nothing really happened. And I said to myself, if nothing's happening, something might not be working right. So I don't want to run it and potentially cause a problem from that. So I turned it off, called my buddy Peter Zila up in Wisconsin, that guy you guys know from my channel that I've made a bunch of videos from. A lot of the work he does is hydraulics based. I told him what's going on, and he basically said, don't with it, it's probably fine, just let it run, because this is, in his words, a high pressure, low volume pump. So it took a while for this thing to pressurize oil and send it all the way through this hose and then all the way into that cylinder, and you know, that's what we were waiting on when it was just sitting there and this wasn't coming down. That's what was actually happening. It was pushing the air out of here and like back out through the vent on the system. Alright, so the other day I asked my buddy Seth to acquire some stuff we can smash, and he came up with a few things.
Yep.
So what do we have here?
Okay, so we got a really old iPod, 160 gig. We can't even tell anymore, but this thing doesn't work anymore, so we don't care about it at all. It was like $300 and then it just stops working. Alright, so we got a really old hard drive right here. This thing is garbage. Like, it's old and it doesn't run fast at all. So we have no problem destroying this. I have no problem. They're mine. That's right. So they're going to be gone now.
Oh, this is gonna be great.
So I think that's about where we want to put them, I suppose.
Yeah, I think that's close, and if it's not, this thing moves slow as molasses, so we can adjust it.
Yeah. Okay, cool.
Alright, let her rip, Tater Chip. This is gonna be great.
Alright, we'll hit our on switch here. And then just a little lever.
You ready to stop it? Okay, put your hand on the lever.
Pressure's going up a little bit. Down the KNIPEX. Pretty awesome. Pretty awesome, gotta say. I'm very impressed. I mean,
Very impressed.
no.
Whoa!
Wow! Wow! I can't believe it.
We're pressing this thing, and I was looking over at Seth because we're both hiding behind the columns, and he's going. We call this one the Clinton Special.
That did it that time.
Yeah.
Oh, just look at that. Oh, oh, there they go. Alright, so we smashed a hole right through it, looks like. There's the Nintendo GameCube, the little glass lid on the top. Let's see, we open it. Hey, it still works like that, you know? That's pretty nice. Eh? Good job, Nintendo. Alright. Wow. Hey.
Awesome.
Yeah.
I thought that one was going to launch.
Well, I thought it was too. I couldn't believe it. It's like an intestine that just shot out.
Alright, so that was with about 2,000 PSI on that gauge, and the gauge goes up to 10,000 PSI. I'm gonna need a pretty awesome press brake for this thing because it is even more powerful than I thought it would be, and I thought this thing would be quite an impressive machine. So what we have here is some, I'm fairly certain this was 2x3, I'm gonna say, rectangular tubing, and this is some incredibly stout stuff. I mean, this is, I believe, 1/4 inch wall. And just so I can show you guys there's no, you know, trick photography here or whatever. Yeah, look at that. 235 thousandths right there. Probably started out at like 250 plus. And it's, get a couple more readings here. Yeah, see 250 exactly right there. So, yeah, this is 2x3 1/4 inch thick of real steel here. And it did it quite easily. So this time we made it up to 4,000 PSI on the gauge, whereas with that thinner piece of pipe we only made it up to 2,000. I really didn't know if it was going to do this, period, honestly. I thought, I really wasn't going to be surprised to see it go either way. But you know what, it hit the top of this thing, it struggled a little bit just until the sides started to bow. Once the sides started to bow, they lost almost all their rigidity, and then from there it was comparatively quite easy to smash this down. 2x3 round stock, this is, or rectangular stock, this is some incredibly solid stuff. You know, for those who might be watching this that aren't really into metalworking or whatever, you can support like a semi with this, the weight of one easily on this cube. And you know, if you had to park one on it or whatever, and it would do it. So this is pretty impressive. I really didn't know if it was going to do this or not. So I guess this means that it's time to plan out a press break and maybe some other stuff. The hydraulic press is a complete success, which is good because we had quite a few setbacks on this project. You know, my regular viewers know my hydraulic cylinder ram got stolen or lost in transit. We had some defective flux core wire, which caused quite a few bad welds we had to grind out and redo. Total pain, but we persevered, and now I have a 50-ton hydraulic press, and I love it. I'm really excited, and I'd just like to thank you guys for watching my videos. And as always, don't forget to rate, comment, and subscribe for more. I'll see you next time.